Okay. Yeah. So yeah, I think people, they can see my screen now. Okay. Yeah. So welcome to a class which is offered by Emzini weCode. So we'll get to introduce and talk more about what Emzini weCode is throughout. You get to meet, like, some of us, and, like, what we're all about and what we're working on. So this is just our general website where you can find some information about Emzini weCode, but that needs to be updated. So we have courses which we offer. So for example, earlier, maybe 2 months ago, we offered our first course, CS7. This was most like an introduction to programming and computer science. So we combine material from, like, top tier institutions like UC Berkeley. UC Berkeley, I'm biased towards that. And then Stanford, Harvard, MIT, and we then try to figure out how we can introduce these core principles to you in an interesting way. And then we'll be teaching this other class also, an introduction to machine learning. This one, can be like maybe like 3 or 4 weeks, just introducing people to the core concept of machine learning. But though some of these other classes and some math classes will be a prerequisite for you to take this one. And then we have another one which we'll be planning after this one, where we'll be introducing people to, like, some concepts in programming and statistical inference. So that's most like giving people a taste of what data science is all about. And then we have CS109, which just introduces people to web design, and if students want to learn HTML, CSS, JavaScript, and all the other, like, JavaScript libraries, they can learn. So we have only offered this one. This is our second offering right now. These other 3 classes that will be offered in future. We might also work with our team to see if we can also maybe, like, offer another maybe class, like introduction to app development using Flutter. I understand that most of the people, they might not really want the theoretical stuff, but then they want the practical side of things. Okay, so CS103. Oh, and we also offer some workshops. For example, we've offered a JavaScript workshop. These other ones, they'll be coming up just in the next few months or few weeks. So just like making sure that if we see a really good skill out there, so we'll be extending those. Maybe, for example, introducing people to React, maybe like Django and all other frameworks. So always check. Yep. Always check our site to see, if they're like more course offerings, and follow our Instagram page. That way you can get, like, our news faster. Okay. So this is our class. So people might wonder, like, why we have all these numbers. So just like CS7, when you say that, oh, that's like our first happy number. So I think, yeah, this one, 103, it's also like, like happy numbers. So we just, like, randomly choose a happy number, and then we just give it to we're assigning it to, like, any course. So this course is going to focus on preparing people for interviews. So the course info mostly, it's we want to give you hands-on practice in solving interview questions. So we'll be covering, like, like topics in data structure and algorithms. And then for those who want help, we'll also be providing resume critique, just to strengthen your resume, to see how you can rephrase, some other project which you have done, and just how you can just make it shine there. We'll also be offering mock interviews. I've some couple of friends of mine who are like software engineers, like at various Silicon Valley companies. So they will be just like offering mock interviews just to stimulate the real world interviews. So almost for throughout this course, each person should at least have had maybe one interview with me, and then maybe two or three interviews with like a software engineer other than me. And then we are using vast amount of material found online. So we'll be posting most of the things, like in the reading tab on the course website. And for those who need to be challenged, you might also add some extra problems. So if you feel like the course is not moving fast enough for you, always let me know. I'm happy to challenge you with more problems. So I think the prerequisites wanted someone to have completed our CS7 class or any other class in computer science, which matches the standard. And you have also maybe you have knowledge of A-level math, or you've taken like a calculus class at school. So we want people to understand recursion, control, and higher order functions, like the basic understanding of how to use terminal, the Python programming language, and also debugging Python code. And then on the mathematics side, if you have good understanding of just the knowledge of how logarithms and exponentials work, that would be good. So I will spend a small amount of time reviewing some of the materials. For example, you're less likely to remember. I think today I'll just go through a very fast recap on some parts in reviewing some Python code, just reviewing arrays and strings, how they are like. And then I'll spend more of the time looking at efficiency, asymptotic analysis, peak or, and how they're different. Okay, and then perhaps more than formal requisites. Yeah. Okay, so I know there are people who haven't they haven't taken much work in Python and all. But then what we're doing is we want people to have the willingness to learn. So if you're willing to learn right now, you can, we're there to help you, so you can help review your Python code. So for a good review of recursion, okay, so someone asked the question, can the problems be done in any other language? Maybe Java. Okay, so I think to standardize, for example, to standardize the course, I would want at least, for example, someone to practice, for example. It's not maybe doing the questions in Python, since most of the material which I've been preparing will be more in Python, where you'll be submitting your code. I'll auto grade some of the code, so the tests which I'll be writing will mostly be specific to executing Python related code. But if you are, for example, during your mock interviews, you may, for example, if you're interviewing with me or you're interviewing with another engineer from through the program, we'll be pairing you with one. You can use any other language which you want. But then, I feel since mostly it's a learning, this course has to strengthen your understanding in Python. So even if you know Java, that's good. But then you can also for example, add a new skill by mastering another language. And personally, I think I find it easier to interview in Python, since it's like, you don't have to like write so many of the other, like it's not verbose like the other programming languages. Yeah, but that's a good question. Okay, so yeah, I think this applies for people who are not here, but like I think if you have I know that some people reached out to me and then they're like, oh, this week they're finishing classes or they have exams. So if you know friends who want to join, just tell them to like reach out to me, and then I can assess them and see where they can jump in within the course, because we'll be solving different problems. So almost each week it's good for someone to join. And then people who might want certification, yeah, if you've shown some reasonable effort, then we can like provide you with certification. Then all assignments, they'll be due at 11:59 p.m. Pacific time. You'll be submitting them in Grayscope. So let's see what other information. Okay. So for resources here, you can like find, extra reading or helpful information. So I'll just be putting it all in here. And also, if any of you find interesting things to share, maybe it's an article or anything, just let me know. I'll just add this. So this page belongs to all of us. So if you see some other like article or it's a Medium post which might explain this problem, or it explains more on the concept of big O or something, just send it my way and then I'll add it to the course website. So yeah, so we have, today is our first lecture. At the end of the lecture, you'll find the lecture video here since we're recording it, and then you can I'll release the problem sets. You'll find them here. And then on Saturday, we're just going to have like just a discussion where it won't be lecture, but we'll just be solving problems, one problem after the other. So for lecture, you might be there for lecture, or you might watch, a recording. The lectures will be, I think for today, this is the one which will be longer, but for the other ones, they will have to be like really short. And then we'll focus most of the time on releasing 5 problems per week. And then, like you work through them, you write the Python code, and then you also submit on Grayscope. And then I'll grade them. And then, for the discussion session, we'll just get to revise them. And then once you all agree, for example, on a course schedule, I will put like I'll update the schedule here. For example, okay, this is the day for lecture, or other. Okay, for example, I'm like, okay, this is the day for lecture. So yeah, I'll update the schedule here. And then for office hours, I'll be having like openings, for office hours. So I'm going to add, this is my calendar. So I'm going to add slots, many slots throughout the week, maybe like 15, like 30-minute slots. Okay. Yep. So yep. So I'll have like many slots. I'll create them today. So if there's something which you didn't understand, maybe during lecture, or you need help, like looking through a problem, you can get help through setting up those slots. I think that way that will work for all of us. So any questions? Okay. Oh, no question. No question. I think that's enough about logistic. So make sure to join the WhatsApp discussion. I was thinking whether we should open a piazza, but like our size is very small. I think WhatsApp can do And then Grayscope, I would add you to Grayscope where you'll be able to like submit your assignment. Okay, there'll be more instructions when I release the problem set. Okay, that's good. That's good. So yeah. So right now I expect that people were able to that were able to get started. Okay, so okay, if you have taken CS7, then your work environment is set up. So if not, then you can like set it up after this. I sent a detailed email when I enrolled you for the class that you should just go and just complete lab 1 so that you can install your things. So just we'll be using Python 3, so you know you can import it here. And yeah, within Python, there are just like so many of these things which you can do. So for today, I'll just like for the next 10 minutes go through a very like fast recap of through a fast recap of the introductions to like to Python, and then from there we'll look at measuring efficiency, and that. So that works. Any questions? Okay, I'm looking at the chart. Okay. Yeah, no questions. So basically, like in Python, we know that you can like enter something, and then it can evaluate and give you an expression. You can also do, for example, the calculations you can add, and you can also like you can add numbers, you can subtract numbers, you can multiply, you can divide. So this is just for maybe people who are coming from other languages. If you know them, then it becomes easier for you to like, for example, you can subtract 2 minus 3, you get an answer. You can multiply 8 times 7, you get an answer. You can divide 9 divided by 4, you get an answer as a float. If you check, for example, what the type of 2.25, okay, I got an error. I was meant to put, the dot. No, it will tell you that this is a float. So a float, basically think of it as a decimal. And then if you want to divide without like, and you don't care about the remainder, you can use float division. And then you can like divide this and you can get 2. But what if you want the remainder? You can get the remainder by using mod, and that's what 9 mod 4 is equal to 1. Basically, if you divide 9 by 4, you get 2, remainder what 1. So that this 1 over 4 is the one which evaluates to what to 0.25. Okay. And then we also know that we say there are call expressions in Python. You can find the match of okay. You can find the match of 2 numbers, 3 and 4, for example. It tells you the answer. You can find the power. Like if you say 100 squared, you get an answer is 10,000. And then you can also, for example, you can even find the power of 2 and 100. You get a really, really long answer. So it basically, it also behaves as your calculator. So the maths can also take in so many arguments. So like you can give it 1, you can give it -2, maybe you can give it 3 and -4, and then it can tell you, okay, this is the max. And then you can also next next nest some expressions within that. Okay, so zoom in your terminal. Okay, yeah, I think it's it's zoomed in right now. Thank you for that. You can also find the mean, maybe the mean of 1 and minus 2, and then maybe you also want to find the mean of maybe finding the power of 3 and 5. Yeah, maybe you want to find the mean of this expression and maybe minus 4. So what this says is you want to find the marks of these two expressions, this one and this one. But in order to evaluate what's outside, you need to evaluate what's inside. So, it finds the mean of 1 minus 2, that's minus 2. Then it also finds the mean of this. So the mean of this then will know that, okay, this will be minus 4. So this expression is just equivalent to finding the marks of what? Of minus 2 and what? And minus 4. That's what this evaluates to, and that's what that also evaluates to. Okay. So we can also import, from operator, we can import functions, for example, like add. You can now add two numbers, 3 and 4. You can also import for subtraction is sub, for multiplication is null, and then you have true division, and you have floor div, and you also have mod. Yes, yeah, I'll be uploading the recording on our YouTube channel. Okay, yeah. So I got a syntax error because of the spelling of sub. So I'll just remove the extra B here. Okay. Oh, from operator import. I'm sorry. Okay. So from operator, what it means is I have a library named operator where these functions are defined. So I just want to use them. So now I can multiply, 3 and 4. I can get an answer. I can find true div of 9 and 4. That's just the same as saying 9 divided by 4. So these two things are used to measure equality. Okay, and then I can also do floor div 9 over 4. Okay, I get my answer, and then I can also do mod 9 and 4. I get 1. So basically the same functionality which exists here, you can also get it by using these arithmetic operators. Okay, so you can also import, we saw that you have this library named operator, but then there are some, for example, called math. So from math, you can import, maybe let's say you import square root. Now you can find the square root of what? Of 64. You can get that the answer is what? It's 8. Okay, so you can also import constants. For example, from math, you can also import something like, okay, let me first start by doing this. If you say pi, you get like a name error. Pi is that like, constant in mathematics, which we use to like, to find, which helps us relate the area and the radius of a circle. So if it's not there, we can actually get it from a library named math. So someone wrote all these mathematical constants and functions. So from math, you can import pi. So now when we say pi, it gives us what pi is. So you can now use it, for example, in your computation. Maybe let's say that gives us, like, for example, some answer. We can now use it. So this is a name which stores a value. You can just use it just like how you do so in mathematics. Okay, and then what else? So you can also import some other things like trig functions, and then now you can find what sine pi over 2 is. Okay, that's one. So for assignment, we can, like, let's say you have a value which you want to assign to a name. You can assign the value 10 to the radius. Now you can find 2 times the radius. You can find an answer there. You can also, for example, calculate the area and the circumference of a circle, and you can assign, this is like multi-line assignment. So this was like just assigning to one variable, but now you can have this one equal sign stands for assignment, and then 2 of them, they're just the one which you use, for example, in your mathematics, and also, like, I think in other languages. So now the area of a circle, we know that is pi times radius and then the circumference, we know that is 2 times pi times radius. So now we know that, okay, what's the value for the area and what's the value for the circumference. So that's how assignments work. So we saw, like, when we're looking at max and power, those are like built-in functions. And then when we imported from those were functions which were already defined somewhere, and then we just got them. But we can also define our own functions. For example, if you want a function which finds the square of x, 1, 2, 3, 4, Python is white space sensitive, so you have to include that. You can just return x times x times x. Now you can just find the square of 9, and then it gives you an answer. Okay. Yeah. And then we also have, for example, when you enter -2, you just get -2. But then when you print, let's say you print -2, it also prints -2. But then if I say let 2 be equal to 2, for example. So if I just query what the value of 2 is, okay, yeah, it will print 2. Yeah, and also that's the same thing. Also, if I print 2, okay, it will also print 2. And then let me have see the result of printing 2. So let's call this, okay, the result of printing 2. So if I say print, I want to print this 2, okay, so I see that it gave me what? It gave me 2, but then if I try to find out what print 2 is, I actually get nothing. But then if I print the result of calling print 2, what I get is I get none. So I'll put some material in resources where you can just go and, like, check from the CS1 lecture just the difference between, like, functions which are like the difference between, like, pure and impure functions. But yeah, I think throughout our discussions, I'll be throwing in most of these examples to help cement your understanding of Python. Okay, so we have okay, we have we have Sublime. Okay, let me just go to okay. So let me create a new folder for CS103. Okay. So inside this folder, this is where we'll be doing most of our demos. So right now it's empty. So I'm going to create a file named demo.py. So files in Python, they have, okay. Yeah, files in Python, they have, they end with the .py extension. So now I want to open that file using Sublime. So yeah, usually like this should be configured. This command should be configured for you. So if you have trouble doing that, reach out to me and then I'll help you fix how you can open Sublime from the command line. So this is where we'll be writing our code. So we write our code here and then we execute it using the terminal. So for example, we can write the code to find the factorial of okay, let me start with a simple one. You can write code to find the square of x, and then what you get is you return x times x. Okay. So now, if you are here, okay, okay. So if you are here inside this folder, so here in demo.py, you would have saved, your file. And then now you can run, for example, if you run Python 3, if you have a Windows machine, it's just Python, and then -i. So -i since, oh yeah, oh thank you very much, my return, yeah, it's meant to have yeah, 1n. Okay, so Python 3 -i, and then you can open that file interactively. So right now, if you say, square, square is already there, and then you can, we can use it. So there are things called doc tests. For example, how you have doc tests is 3 quotation, opening quotation and closing quotation, and in here you can describe, what the function is supposed to do. If this square is meant to compute the square of a number. Okay, so how does it compute the square of a number? If you enter it in terminal, for example, if we say what's the square of 9, then we say a is equal to the square of 7, and then we say a is equal to 49. So basically, if you get this, and then you come and paste it here. Okay, so they should be your doc tests. I'm just going to indent them like this. Okay, so if you have something like this tells, these are called doc tests in Python. It says whatever code is written in here, this is how it should behave. Like I should be able to open it interactively and enter this. If I enter square of 9, I should get 81. If I enter this, I should get nothing. If I enter 8, then I should get 49. So we use this approach, this test-driven approach, to figure out, even before you have an idea of how your code would work, you can like write this doc test, and then from there you can then solve your code. So if I exit here, so you can run, and maybe let me first make this to be wrong. Let me just say return 0. Okay. So if you run the command Python 3 -m, doc test. You can basically run a command to run those doc tests to execute the code inside this triple quote. So you can then you write the name of the file, demo.py. So it tells you in this case that okay, you have failed examples in this file in line 5. It tried to execute square 9. It expected to get 81, but it got towards 0 because everything is returning 0. And then for this one, it said it also had a failed example in line 8. When you wanted to get A, you are meant to get 49, but you got what? You got 0. So now when you now have your test, written in your doc test, it then gives you an idea on how you can move forward with implementing your question. So this test driven logic, it forms the basis of what we'll be using when we'll be solving most of our problems, or when an interviewer gives you, gives you a problem to solve. Already there are tests, in special cases on how you handle it, how it's meant to behave. So make sure that before you just jump into a problem, understand how it's meant to pass the test, or how it meant to behave, just given different kinds of inputs which you put in there. Okay, so yeah, I think that's like almost enough intro for now. So those are just like the miscellaneous questions. Does anyone have any questions before I just continue a little bit? Okay. No one has questions. No one has questions. Okay. So yeah, I'll go back to my Python thing here, and then we can just do so we have these things. A pound sign, represents a comment in Python. So we have something called lists. So a list is it's a way of storing storing stuff. So it basically represents a block in memory which you might have reserved. I'm going to release more notes, which you guys can just read and practice on lists. But I'll just go through how list works in Python. For example, if you have, let me just have 4 odd numbers. You have 41, 43, maybe 47, and 49. Okay, so this is a list. It has the square brackets. It's just elements wrapped by square brackets. So you can find that, okay, this is that's odd. These are odd numbers. So the properties of the list, you can find the length of the list. Okay. It tells you that there are 4 elements in there. And then you can access the elements. For example, if you say odd, and then using this square bracket notation, so it's an element selector, you can find, for example, okay, what's the element which is at index 1? It tells you that is 43. So this is at index. Index means the position. Lists or arrays, they start with position what? 0, 1, 2, 3. Okay. Or -1, -2, -3, -4. For example, if we find what's the element at index -3, we also get what? 43. So basically how it works is, this is okay, if we start this one, this is index 0, this is 1, this is 2, this is 3. Okay, let's start from 3 going backwards. So we have 3, 2, 1, 0, -1, -2, -3, -4, Actually, let me check if -5. Okay, no, I don't think that will work. If you do -5, I think it should just be out of bounds. Yeah. But basically, like you can either start counting from like 0 going this way, or from -1, -2, -3, starting from like from right, yeah, to left. Okay. What else? What else? You can let's say if you have odds, you can, for example, get the element which is at index 0, and you can also multiply it by the element which is at index, for example, 3. Yeah, and then you can maybe let's say want to add, let's add the length of what odds is. So basically, like you can like get something. Yep. So this one we're just like getting odds at 0. This was 41 times what at index 3, that's 49. Or what does -m do? Okay, so for the Python thing, -m is more of a flag to, yeah, it just tells, it's like it's an option, like yeah, something in Python. So it tells, for example, when you say -m dot test, it kind of explains. Okay, so I think I wrote it somewhere in the code for Emzini weCode. Okay, I forgot that URL, but let me just show where the information is, mostly where you can. Okay, so if you come here, like it's one thing, like -m dot test. So it's just Python's way of specifying how to run doc tests in a particular file. So yeah, this was also just there like in lab 2, like in lab 1 or in lab 2 of CS7. You can just go and like click, some reviews on like using Python or division if this is shaky, but I was just going through like a fast recap so that it to be easier. Okay, for everyone. Okay, so yeah. Yeah, and then let's say we also have a list called digits, which is 1, 8, 2, 8. Okay, so we can have, for example, like we can have functions. Let's say, okay, let me write it here. Okay. Okay, while loop, for loop. Okay. In the interest of time, I'll just add this as an extra assignment, and I think I won't have more time to cover efficiency, because I feel like what I'm going to say here, I'm going to say it anyway. So let me just go to my slide, and then we do what's interesting. Okay. So yeah. Okay. So I'm going to play from the current slide. So when we'll be solving our problems throughout this course, interviewing problems, they are all about like finding efficiency. So when you're interviewing for jobs, they don't really care. Oh, they know you can find the solution, but then they want you, if you find the solution, does it take so much time for you, for example, like with you like finding that solution? So when we measure efficiency, let's look at, so I expected that, people, they have some understanding of recursion. So let's look at how you can compute recursion using the Fibonacci sequence. So this is how we would define fib. So if someone doesn't understand this, it's okay. You get more time to go back, and review. So this is the Fibonacci, how we define the Fibonacci sequence in Python. It's kind of like, if n is 0 or n is 1, we just return that. Those are the base cases. And from that, how you get the next Fibonacci number is adding the result of the previous two. Okay, so that's the guy Fibonacci. So when you say Fib5, for example, how do you get Fib5? You get Fib5 by adding the result of what? Calling Fib3 and Fib4. How do you get Fib3? You add Fib1 and Fib2. These are the previous one. And then for Fib1, if n is 1, that's the base case, we just return 1. And also that's true for what? For Fib0. So from here, you can just see how this recursive function, which calls itself, how it branches out. Okay. So now, if we look at when it calls Fib3 and when it calls Fib4, this is our this forms like our computation tree. So let's see how where it is the base case. For example, for Fib1, it's going to get 1 here, and then so these are just the different calls, the order in which it's called. So in order to get Fib3, it needs to know what Fib1 and Fib2 are. But in order to know what Fib2 is, it needs to know this one. So this is the order of the calls, how the calls are made. Then now when it comes to Fib4, it first needs to evaluate these lower ones so that it can actually come up with the computation. So if we look at this order, these are like, the number of calls, which are made. Okay. And then finally, it will combine the results in Fib5. So if we look at this seems to take more time because, for example, when it computed Fib3, it had to find out what Fib2 was. Okay, and then you found what Fib3 was. But then now when you're trying to compute Fib4, basically, if you look at this branch is this entire one. And if you look at this branch Fib2, that's also this entire branch. So now for you to find the result of Fib4, basically after computing the value for Fib3 here, we wanted to know what the value for Fib4 was. So if there was a way in which we're storing these previous values, then we'll save so much time because we'll just get those values rather than having to compute them. For example, you can see that this tree, the time it takes to compute only this one is the same as the time it takes to compute this one. So now sometimes you might write, your code, you might implement your solutions, but when you are interviewing with interviewers, they're looking if you can write code which is fast and which also takes less space. So there's this thing, for example, with memoization. So it's think of it as a cache. So what you're doing is you are remembering the results that you have computed before. So for example, if this is writing the function, the code on how we can compute the Fibonacci numbers faster. Okay, so we can have this higher order function. So what we have is inside we have a cache, which will be a dictionary. So now this memoized of n is the one which will compute the Fibonacci number which we need. So we're saying before you call Fib1 or fib2 or fib3, you first check if that n, the number which you have, we haven't stored. So what our cache will be doing, it will be storing, for example, some sort of a key value pair, like saying, if you have computed fib4, don't compute it again, just get the answer, just retrieve it. Or if you have computed fib5, just retrieve it. So if the number is not in the cache, then we'd want to then compute it and then add it, to the cache. And then, or else we just get the result of what that computation might have been, because we would have stored it before. So we just get it and then we retrieve it from the cache. And then the result is just returning, like the memoize function. So now if we look at how this cache looks like, so if we see this data structure, this is a dictionary, or in other languages, you can think of it as a hash map. So you have keys, they are like arguments. You can think of them as the arguments that map to what? To return values. So yeah. So let me just see how we can demo this memoized code here. So if you have any questions, I know I'm like left with 27 minutes to cover this. So if you have any questions, ask me in the chat. I'll be happy to answer them. Okay, any questions before we go to code writing and mathematics? And okay, no questions. Okay, so let's try to. Okay, I need to mute someone. Okay, let's try to see how we can have this, this property of just writing code which might be fast. Okay, so would want to look at at time. So let's define a function called count. So what count should do, I'm going to put some tests here. So it should, let's say it returns a counted version of our function f with a call count attribute. So it's important for us to understand this notion of time, so that when we write our code, our code will be faster. Okay, so let's see how, for example, would want time to be used. So let's say you let's say you have okay, so let's say you have you define a function, for example, like let's say you define a function called fib. Okay, so 1, 2, 3. So yeah, I think let me define this function here so that I can copy it in my doc test. So if you define a function called fib 2, 3, 4. And then if n is equal to 0, okay. If n is equal to 0 or n is equal to 1. 1, 2, 3, 4, 5, 6, 7, 8. What I would want to do would just be to return n. So that's the base case. Else, oh, else I just want to return the result of calling fib of n minus 2 plus fib of n minus 1. Okay. Yep. So yeah, I just wanted to copy this so that I can like put it here in my doc tests. Okay. Yeah. So let's say like if we have if we have code like that, and then now what I would want to do is to will be to then calculate and find, let's say I have fib is equal to to the count of fib. Okay, and then now I call fib, fib 20. So if I call fib 20, let's say I want to get something like 6, 7, 6, 5. Oh, these are pre-computed values. And then and let's say if I call fib dot call count, call, okay, let me see, call count, I get something like 21891. Okay, so this function we're going to use it, just as a way of as a way of understanding our code, how how Fibonacci runs and why we need to memorize it. So now we can define, for example, like some counted, which takes in so if you don't worry much about the syntax, but then what we have is we have this counted dot call count, which has to we increase it by 1 every time when our function is called, and then we can then call the function with this whatever argument. Okay, so what does fn do? Which fn? Fn of, oh, you mean this one? Oh, okay, so this is a function. So if this function was saying based on, for example, on how you'd call it, for example, like in this case, our f is what? Is fib. So now, for example, when we then like call it n will just be, so this count just works either for the fib function or the factorial function. It just counts the number of times, like that f is called. And then we just gave it like a call count attribute. Yeah, I think I might be speaking to myself. yeah, I usually notice that if like just on and on and yeah. But yeah, people ask me questions, Okay. So whilst I'm waiting for the questions on the chat, I'll just continue writing the code. So this will make sense more in a this will make sense in a bit. Okay. Yeah. And then we return counted. Okay. So now if I save this and then if I run this file interactively, I can just see, for example, if I say what's the help of count, it tells me what we wrote, in the doc test. So you can escape this. So let's see, how many times. Let's say I have fib 5. Okay. Oh, I have to define what fib is. Let me just get this copy. Yeah, so this is just to define the function so that I'll be able to use it. And then I exit again because I've made changes, so I need to run it on a fresh interactive session. So what's fib? Okay, fib was defined there. So let's say I have let me just call it 5. It's equal to the count fib. Okay. What's 5? So 5 becomes this function. So this is a higher order function, which returns what? Which returns counted. So what it does when I say count fib, I'm basically passing this function f as fib. And then what it does, it initializes this call count out attribute to be 0. And then it returns what? Counted. So now 5 is basically this function now called counted. So now if I want to find what fib 5, so I just say it like fib 5, you can yep. So it's okay, let me just say 5. Okay, 20. So okay, so if you look for example, like at this logic, okay, let me okay, so I'll exit this and then read through this so that I can show you in the okay. So if you have let me name it fib 5 so that it won't be confusing. Okay. So if I call fib 5 and then I pass in, for example, the 5, and then now if I say fib 5 and then dot call count, okay, it called it once, but then like if I call, let me say if I call fib 20, okay, and then if I call fib 100. If I call fib 100, it takes more time to compute. So you have to like wait a couple of seconds, because what it's basically doing is repeating all the different steps, of fib. For example, it has to find fib 99, fib 98, it has to find fib 90. So what memoization does, it helps us keep, for example, like some storage on how our program might run. Okay, so I'm going to include this in the demo. So I just want to, like, since I'm left with like 18 minutes, I want to finish.
Can I ask something?
Yeah.
Like the dot call count on the count function.
Yep, this one.
Yeah. Where are we getting the call count? And yeah.
Like, where are we getting? So this is a higher order like function. So when you define it, like, you have this count is when it's in the global frame, and then this counted one, it's a local. So it's returning this counted inner function, but then this within. So I think maybe I might, like, using environment diagrams might make it more easier for us to, like, to see, like, so since it's a local function, for example, when you call, let me, okay, oh, it's still trying to find fib 100. So that's the property, for example, of how higher order functions work. So it remembers, because this is where we defined it, but it remembers it from the scope in which that counted function is also initialized.
Oh, so and I see. Okay, yeah. I thought maybe call count was some kind of instance of a function, but now I think I see where it was like initialized.
It's an attribute. So it was initialized here. So you remember, like, how like, for example, when you call this count function, what happens, for example, when you say count fib and we initialize that to fib5. So what it does is it will read line 19, and it will know that you are defining a function, but it doesn't get inside. And then now it will also, like, just come and, like, initialize initialize this variable. So what you here, you would have say that, okay, let count, since we also spoke as functions as, like, these special kinds of objects in CS3, when we're talking about object oriented programming and all. So it puts this attribute, this dot expression, that says this counted thing which you'd have had, let's initialize this variable called count.
All right.
Okay, and then it just returns you the function. So now every time when you call that function, it's able to, like, to keep track within that local scope of the number of times the function has been called.
Okay. And then so can you also explain, like, the arguments part, why we're having multiple arguments there?
Oh, okay. So this multiple arguments, it's just since this code is written to be generic, for example, you're like, you don't really care. F might have 1 or 2 or 3 or 4 arguments. So this multiple arguments just says whatever, because you might sometimes, maybe, let's say since this count takes in any function, you know, and functions are different. Maybe you might want it to keep track of the count of the function. Maybe it can be, for example, the Fibonacci function, or it can be another function, for example, which might take, you know, have like all those arguments. So what we're saying is this multiple args, it's think of it as a placeholder for what? For this n for fib. So if maybe like fib at 1 and then, you know, at x and at y, then there's multiple args. Because if you see, you know, by passing them to the function, so it doesn't matter, because in this case, the multiple args will just be, you know, this one, just passing them to the call of this function.
All right.
Yeah. So that's
and then
why
the return part for the counted function, like the inner function, how come we have the f args? Why are we returning like f args?
So for example, like okay, so let's think of it. Let's say if this was n, okay, then this will be n, and also this will be n. So for example, if here we passed in fib as a function, okay, and then this will be n, and then this will be what? Fib of n. So that this you know, this all like multiple arguments. But then the next time, if we passed in, you know, maybe another function, maybe like, let's say we passed in ping pong, you know, and then this changes to ping pong. Maybe, you know, maybe let's say now ping pong has to take in A and B. Then that also means that, you know, here, yeah, things change. So that now we don't have to to specify all of that. We can just have like, you know, some placeholder, like, you know, multiple args, and then that can be generic for any of the function calls which we'll be able to make.
All right.
Okay. Yeah. So let me go through just like, well, I left with like 6 minutes and then finish these slides, and then people have more questions, they can like, yeah, ask afterwards. Okay, so with memoized replication, when we make a call to fib, for example, when we want to find what fib5 was, you know, it makes this call the first call to fib, because there's no fib1, and then it makes the call to fib0. Then now when it wants to find this fib1, it finds it in the cache, in the storage. And then now it makes the call to fib2, it makes the call to fib3. So now it has made, you know, these 4 calls, but it has saved the results. So now when it comes to this other side of the tree, basically when it's at fib2, it knows that, oh, fib2, we have already committed fib2, so it makes this call to fib2. So now it skips all of that. And now when it wants to find what fib3 is, it knows that, oh, you have also calculated fib3. So it now skips all this computation. No, they are skipped. Then it just finds fib4 and then it finds fib5. So at the end, we just find that, you know, by not opening up, you are like saving more on space and also saving more on time. If you look at our code to find fib100, it's still running right now, but the code is memoized. But if we wrote the code, because it's still repeating the same process, but if we wrote the code in a different way, then it would have been like would have finished like, you know, seconds ago. Okay, so I'll include more information also on that. let's okay, left with 4 minutes. I don't want to like take more of people's time. So let me rush through this. So we have something called the space. So everything, it takes like space within a computer, like your like RAM and all that kind of stuff. So any computation requires space. So the consumption of space, think of it, when we're looking at environment diagrams, thinking of the frames. So the frames which we need to keep during an evaluation, at any moment, those are like, for example, factorial, n. So if you want to find the factorial of 10, you have to open frames up until the base case. So you know that at most you will need to have n frames. So that's like, it's a measure of the consumption of space which a function might have. So values and frames in active environments, they consume memory. Memory that is used for other values and frames can be recycled. Yeah, so I'm going to also add the slides and people that can ask me more questions anytime. So let's see how Fibonacci uses space. So this is the Fibonacci code. So let's assume we've reached, like for example, this step. Let's try to see, okay. So if we've reached this step, then this is not the memoize. This is just the basic Fibonacci. We're trying to see how, like, which one is the active environment, which one is not. So this, it will have an active environment. But then these other ones, for example, they can be reclaimed. And these ones, they haven't been created. So this is just like, we're saying the black ones, it says, okay, the environment is active because this space, they've finished computing this, but we haven't finished computing 5 because we're waiting on Fib4, but Fib4 is waiting on Fib2. This one we've closed it, but this one is still open. So now, if you look, you can see that, there is a way in which, like this is consuming up space. So when we write our code, we have to write code to make sure that some of these like the space which has been used, we can also we can also reclaim it so that we space our code is using. And then when it also comes to time, okay, I think I might be running out of time, but I'm going to write more notes and upload them on the site to explain this part. And then on Saturday, we'll be solving problems. So I'll release problems tonight, and then people that can work through them and then submit maybe Saturday or so. And then on Saturday, we'll just go through those problems. But next week, at least, we'll have covered most of the portals, like the holes, which people have in like different understanding of Python. And then we'll be just solving one problem after the other. Okay, so thank you very much. Thank you very much. I will end